Our focus standard for today's lesson comes from Grade 7, Geometry Standard 6. Calculate the volume of 3D objects composed of polygons and prisms. Today's topic comes from Analyzing Geometry Relationships, Volume of Compound Figures. Our essential question is, how can we break down compound figures to find the total volume? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header along with today's date, set your question column and your note column, and resume the video when you're ready to begin. In today's lesson, we are going to go over 3 examples of compound figures and how to find the volume of them. So here's our first example, where we're being asked to find the volume of these wooden dollhouse stairs. It's important to realize what we mean by compound figures. You might be able to guess from this picture that it's when we take some basic polygon shapes or prisms, any three-dimensional figure, and we start to put them together to make a more unique shape. In this figure for the dollhouse stairs, you can see that it is made out of 2 rectangles. So now we can see that here is one rectangular prism, and here's a second one. When we're finding the volume of compound figures, we're still using that general formula that volume is equal to base, capital B, base times height, where that capital B stands for the area of the base of that prism or that polygon 3D figure times the height to give us that total volume. And so with a compound figure, we're going to break it apart. And so I'm going to consider this one A, and this second rectangular prism part B, and we're going to find the volume of each of them and then add it together to find the total volume. So you may feel comfortable with enough information given here to stop the video and do your calculations, or I can show you a little bit more of the setup before we begin. Since both of the prisms that we've broken this compound figure into are rectangular prism, then we're going to basically use that length times width to find the area of the base times the height of each of them to find the volume of each part before we combine them together. So for the one that I'm referring to as A, if we were to break it right here, I'm going to say that it has a length of 10 centimeters because I can see that this edge is 10 centimeters and there's a number of congruent sides there. Since this edge length is 10 centimeters, so is this one, and this one. So this top rectangle has the dimensions of a length of 10 and a width of 3. So I'm going to fill those values in, as well as the height of this prism, which is 7 centimeters, and begin my calculation. So at this point, I have finished my calculations for finding the volume of this first prism part that were labeled A, and found by plugging in the values and calculating it through that it has a volume of 210 centimeters cubed. So now I'm ready to start filling in my values for the second prism that is also a rectangular prism, and fill in my values and begin my calculation. But I noticed as I was getting ready to do that, maybe you've noticed this too, that we're missing a dimension. So if we again start thinking about this top rectangle, we know that it still has a length of 10 centimeters, but what is this value here? It doesn't say. Is it 8? Well, no, because 8 centimeters is the total distance across. So we have to do a little bit of calculation. We can see from the diagram labeled at the top that this edge is 3 centimeters. So if it is 3 centimeters right here, then this part down here is also 3 centimeters. So 8 minus 3 would be 5. So this is 5 centimeters, as well as this top edge up here would be congruent to that and be 5 centimeters as well. So now we know that the dimensions of this top rectangle are a 5 by 10 centimeter rectangle, and it has a height of 4 centimeters. If you haven't done so already, let's finish the calculations for the volume of this second prism. In plugging in those values, we find that the volume of this prism B is 200 centimeters cubed. And now to find the total volume, just like as I mentioned up here, we're just going to combine these two values. So the total volume of these wooden dollhouse stairs, and combining those two calculations together, is 410 centimeters cubed. Let's go ahead and try our next example. Here's our second example, and we're being asked to find the volume of this 3D figure. It almost has a house shape to it. So let's once again break it into two prisms that we recognize. Do you see them? Yeah. I've noticed this bottom prism is a rectangular prism. You can see that because all the faces are rectangles. And this top piece is a triangular prism. So just like our last video, we're still using this generic volume formula. Volume equals the base, the area of the base times the height. And how we find the area of that base depends on the type of prism it is. So do you know what you're going to fill in next, or which formulas you're going to use to find the area of that base before we multiply it by height? For this bottom prism, we're calculating still with length times width times height, since it's a rectangular prism. And since our top prism that we're referring to as the shape B is a triangular prism, based on this face here, we're going to use the area of a triangle, base times the bottom edge of that triangle, times the height divided by 2, all of that as the area of the base being multiplied by the height of the prism, which in this case we need to pay really close attention to which value that is, because we don't want to confuse the height with the prism with the height of the triangle. So at this point, if you feel comfortable, go ahead and pause the video to fill in your values into the formula and do your calculations and check back. Otherwise, you can follow along with me as I do this first calculation of the bottom rectangular prism. So I've completed my calculations for the volume of the rectangular prism, part A, and found that it was 240 centimeters cubed. Now I'm ready to plug in the values for the triangular prism. And I'm going to use that it has a base of 8 centimeters, because I can see that this edge would be the base of that triangle, and it is congruent with this edge of the rectangular prism. And I'm going to use a height of that triangle, because it's showing me in this diagram from the point to this line, and showing it in a vertical direction, is 4 centimeters. So that will be what I plug in here. So what do you think I'm going to plug in for the height of the prism? Well, if you said 5, I'd agree with you, because this is the face of the prism, the triangular, and we already talked about those dimensions, and it goes back this far. That is what we mean, that's that depth, and oftentimes referred to as the height of that prism, if we were to stand it on its triangular face. So for this height of the prism, we're going to use 5 centimeters. Go ahead and complete your calculations and check back to see if we agree. How'd you do? By plugging in those values that we had discussed, 8 for the base of the triangle, 4 for the height of the triangle, gave me a total volume of that triangular prism as 80 centimeters cubed. Now I'm ready to combine them to find my total volume. So the total volume of this 3D figure with the rectangular prism and the triangular prism combined would be 320 centimeters cubed. Let's look at one last example. Here's our third example, and we're being asked to find the volume of the solid section of this figure. This is an important example to include because I want you to notice that in this instance, because of the way that this shape is drawn and what they're trying to show us, it's not completely solid. They've taken a square prism with a 5 by 5 dimension, and they've cut out a 2 by 2 square prism from the center of it. So when we're finding the volume, we just want to know what is the volume of that solid section, the area of that all the way back. Well, we do it much the same way. We still find the area of this larger square prism as our volume of part A, and then we can find the volume of this inner square prism that they cut out, and instead of adding them together, we can simply subtract it. So go ahead and jump in with your calculations and let's see if we agree. Well, using the same basic length times width times height is 200 centimeters squared for the larger part of this prism, and the cutout, which is a 2 by 2 square, gave us a 32 centimeters cubed for the part that was cut out. So again, since it's cut out, we're going to subtract this value from the larger value to see what is the remaining section. In doing so, we would find that the total volume of just the solid section of this figure would be 168 centimeters cubed. And that's going to conclude our video for today on the volume of compound figures.